Good morning all. Now I would like to explain about superposition theorem. Okay. The statement of superposition theorem is in any linear bilateral network consisting of two or more sources, current flowing through any element is equals to algebraic sum of all currents when we consider each source separately. See here, these are the practical circuit diagrams. Here I need to verify this current is equals to sum of these currents when we consider each source separately, right? First of all, I would like to connect first circuit diagram. Now see here from this figure, RPS positive is connected at one point. At that point 1 kilo ohm resistor starting point is connected, right? See here, RPS positive is connected at one point. Okay, in that same column 1 kilo ohm resistor starting point is connected. Okay, 1 kilo ohm resistor starting point is connected. 1 kilo ohm resistor ending point is connected at another point. Okay, next at this point another 2.2 kilo ohm resistor starting point is connected. Next, this 2.2 kilo ohm resistor ending point is connected at another different point. Okay, next at this 2.2 kilo ohm resistor ending point ammeter positive is connected. Just to remember one thing, in case of breadboard, all common points will be connected in one column. That is first 1, 2, 3, 4, 5. These 5 points, all common points will be connected. This is one port, this is another again. For these 5 points, again these 5 points. These straight line points will be different points. Okay, now see here. After that, again at this point, another 1 kilo ohm resistor starting point is connected, right? Next, this 1 kilo ohm resistor ending is connected at another different point. Next, at this 1 kilo ohm resistor ending point, second RPS positive is connected. After that, RPS negative is connected to ground. Here ground I am using here. Next, first RPS negative is also connected to ground, right? Next, ammeter negative is connected to ground. Here ground is having 3 terminals, right? Ground is having 3 terminals. Now connections are over. Okay, now once you can check the connections, RPS positive to 1 kilo ohm starting point, 1 kilo ohm resistor ending point is connected at one point. At that point 2.2 kilo ohm resistor starting point, and again another 1 kilo ohm resistor starting point. 3 resistors are connected at common point, and 2.2 kilo ohm resistor ending point is connected at another different point. At that point ammeter positive, ammeter negative is connected to ground, and first RPS negative is also connected to ground, and second RPS negative is also connected to ground. These are the connections, right? Now coming to the procedure, connections made as per the circuit diagram, right? Switch on the power supply. Okay, now see here, by varying RPS, see the tabular form. Initially set V1 to 5 volts and V2 to 10 volts. Okay, note down the corresponding current values. First case 5 volts and 10 volts, second case 10 volts and 15 volts, third case 15 and 20 volts. Now see here, I am varying the RPS, right? Okay, V1 set to 5 volts, V2 value set to 10 volts, Now see here, V1 is 5 volts and V2 is 10 volts. Okay, then current is 2.8 milliamperes. Current is 2.8 milliamperes when two sources are acting alone. Theoretical values are 2.7 milliamperes, practical is 2.8, approximately equal, right? Next case, V1 set to 10 volts. Okay, V1 set to 10 volts and V2 set to 15 volts. Okay, note down the corresponding ammeter reading, right? That is here 4.8 milliamperes, theoretical value will be 4.63, approximately equal, right? Similarly, vary the channel 1 voltage, that is V1 set to 15 volts and V2 set to 20 volts. Yes, then the corresponding current ammeter reading will be 6.8. Here it is 6.49, approximately equal. Okay, these are the practical calculations when we consider two sources simultaneously. Now here, next case I am considering only one source is acting alone, remaining source will be replaced by short circuit. Okay, for that one, here I need to connect first circuit diagram. Okay, now here bring RPS position to 0. Okay, and switch off the power supply. Okay, next observe here, up to this portion current circuit diagram is same, right? At 1 kilo ohm resistor ending point is connected at one point. Okay, remove the second channel supply terminals, that is RPS secondary channel, right? Here 1 kilo ohm resistor is connected at one point. Okay, from that point ammeter negative is connected to ground, right? At that point 1 kilo ohm resistor ending point is connected, right? Now here I am using this section total as ground, 1 2 3 4 5, these 5 sections act as a ground, right? Here I can connect this 1 kilo ohm resistor connected to ground, right? Now see here, same procedure again, connections made as per the circuit diagram based upon this circuit diagram. Okay, next switch on the power supply. Okay, vary the supply voltage. Vary the RPS voltage to 5 volts. Okay, and note down the corresponding ammeter reading, right? For 5 volts your current is 1 milliampere, theoretically 0.927, approximately equal. Similarly, vary the channel 1 voltage to 10 volts. Okay, then current reading will be 2 milliamperes. Here theoretical value is 1.85, approximately equal 1.9 or 2. Okay, better you can write 1.9 milliamperes, right? Next, similarly vary the RPS voltage to 15 volts. Okay, then corresponding ammeter reading will be 2.9 milliamperes. Here theoretical value will be 2.7, right? Approximately equal. Okay, after that reduce RPS voltage to 0. Okay, reduce RPS voltage to 0. Next, connect the channel 2, that is switch off the power supply, right? Remove this channel 1 supply terminals, right? Next, see here, RPS positive, this is the circuit diagram, right? Here RPS positive is connected to RPS positive is connected to 1 kilo ohm resistor starting point, 1 kilo ohm resistor ending point is connected at one point. At that point another 1 kilo ohm resistor starting point. At that point only 2.2 kilo ohm resistor starting point, 2.2 kilo ohm resistor ending point is connected at one point. At that point ammeter positive. Okay, next ammeter negative is connected at ground. Here ground I can use here. Next this 1 kilo ohm resistor ending is connected to ground again. Okay, now connections are over, right? Okay, now coming to procedure, connections are made as per the circuit diagram, right? Switch on the power supply. See here RPS negative is also connected to ground. Yes, ground is having three terminals, right? Okay, ammeter negative, RPS negative and 1 kilo ohm resistor ending, right? Three terminals, ground is over. Now connections are made as per the circuit diagram. Switch on the power supply. Okay, now vary the channel 2, that is from the circuit diagram vary the supply voltage to 10 volts, 15 volts, 20 volts and channel 1 voltage set to 0, right? Here I am varying second channel voltage to 10 volts. Then corresponding ammeter reading is 1.9 milliamperes. See here, theoretical value will be 1.85, practical value is 1.9, approximately equal. Similarly set channel 2 voltage to 15 volts. For 15 volts ammeter reads 2.9 milliamperes, theoretical value will be 2.77, approximately equal, right? Similarly vary the RPS voltage to 20 volts and note down the corresponding ammeter reading. Right, 20 volts, the current value will be 3.8 milliamperes, theoretically 3.7, right? Now you can observe the readings for practical values. When we consider two sources acting alone, for 5 volts and 10 volts current is 2.8. When we acting 5 volt source alone 1, when acting 10 volt source alone 1.9, that is 2.8 is equals to 1 plus 1.9, that is 2.9, approximately equal. Similarly 4.8 is equals to 1.9 plus 2.9, that is 4.8, satisfied. Here 6.8 is equals to 2.9 plus 3.8, that is 6.7, approximately equal, right? That means current flowing through any branch when we consider two sources simultaneously is equals to algebraic sum of all currents when we consider each source separately and remaining sources are replaced by short circuit, right? Okay, in this way we can calculate current by using superposition theorem. See here, reduce RPS voltage to 0, right, and switch off the power supply. Okay, this is the procedure to calculate currents by using superposition theorem.